Hello, I'm Kana Bito. I would like to present an automatic memory movie editing system using dashcam video data. In this study, we developed a prototype system that can automatically select video highlights of an automobile trip from dashcam video data and generate a travel video summary. Introduction. Automobiles have been equipped with a large number of cameras and sensors, allowing the experience of riding in an automobile to be recorded in detail. But this sensor information is used mainly for safety purposes. In the past few years, in-vehicle systems that display virtual games and information about nearby businesses have been proposed as new applications for the video and other sensor information data obtained from vehicles. These applications are aimed at improving user experience during the trip, but very few studies have focused on after-travel UX. Therefore, this study focuses on post-trip reflection and entertainment, intending to improve post-ride UX. When developing the prototype system, we focused on dashcams, which have rapidly become popular in recent years. Many recently manufactured dashcams record high-quality video of the interior of the vehicle and exterior driving environment. So, the video data from a dashcam would be useful material for a travel movie. However, editing dashcam video requires a lot of time and effort. To address this problem, we have created a prototype of an automatic summarization system of road trip video using dashcam data and 3 types of sensors. Overview. This is the hardware used to create this prototype. We used a Jupiter Q20P dashcam. It can shoot 360 degrees horizontally and is equipped with a GPS positioning function. The acquired data recorded on an SD card as MP4 and NMR files, respectively. For MP4 and NMR files data, one file consists of 1 minute of data. Each MP4 file is divided into 2 parts, outside the vehicle and inside the vehicle. GPS position information is recorded in the NMR file every second. In this study, we will use the coordinate information and time information. The coordinate information is converted to the surrounding area information using the Location Information API of Yahoo Japan. This is the procedure for using the automatic video editing system. Step 1. Start the dashcam and begin driving. Step 2. After the trip, import the SD card data from the dashcam and the photos taken during the trip into the PC that is running the system. Step 3. Start the automatic video editing program. Automatic editing system. The proposed system performs 5 processes. I will introduce these processes one by one. The first step is to adjust the video size and brightness. When a scene is selected, the center of the upper or lower video is copied and resized to the output size of the HD video. Since the primary purpose of dashcam is to record videos of the area outside of the vehicle, the camera exposure is adjusted to the right level of the scenery outside. So, we adjust the brightness for videos of the inside of the car. The next step is to automatic detection and selection of highlight scenes. Our system automatically extracts the following 9 scenes that noteworthy events occur during the trip. First, departure. Second, arrival. The dashcam is powered by ACC power line of the car, so we judged that the vehicle had arrived at the resting point or destination when the interval of the NMR timestamp exceeds 10 minutes. Third, changes in geographical area. In this study, we selected scenes that included the crossing of a prefectural border. Fourth, landmarks. We obtained regional landmark information such as the names of large facilities, sightseeing spots, and local place names. Fifth, expressway entrances and exits. In this study, we use the vehicle's field information to detect entrances of the expressway. Sixth, lively conversations. Scenes that featured lively conversations were identified using audio data. Seventh, eighth, and ninth are when the switch is activated. A lead switch detected the opening and closing of the door. A mat switch detected when a seat was occupied or vacated. And manual record buttons allows users to extract the scenes they want. The next step is to adding photos taken during the trip. Photos are displayed at the appropriate position in the travel video, using EXIF information embedded in a photo taken on a trip. The next step is to generating a progress map. When traveling by car, geographic information about the route and the current location of the vehicle are also important. So, about the recorded 1-minute files that were not selected highlight scenes, two types of representation methods were adapted, depending on the amount of change in the scenery outside. Left is when the change in the scenery outside the vehicle is large, and right is when the change in scenery is assumed to be small. The last step is merging the highlight videos and adding special effects. If you connect the highlight scenes you have created so far as there, the screen will change frequently and the video will be difficult to watch. So, 3 low-pass filter processing is applied in order to suppress the change. And these 3 visual effects and some sound effects were applied where necessary. By adding these special effects and merging the video in chronological order, a summary video will be completed. Experiment. I applied this system to the 5 family trips. During these trips, an experiment was conducted to compare automatic editing with manual editing. Manual editing was done by my mother and brother. My mother participated in the trip and my brother did not participate in the trip. Result and discussion. Manual editing requires a lot of time compared to automatic editing. However, the number of highlight scenes and special effects used by the automated system was almost the same or more than those used during manual editing. The consistency rate was low for all of the comparisons. The likely reason for the low correlation between manual editors was that the scenes that each person wanted to include in the video were different. When asked what was important when editing the video, P1 said, to include funny remarks and interesting conversations, while P2 said, to understand the flow of the trip. One possible reason for the low correlation between the manually and automatically edited videos is that they have different focuses and different strengths and weaknesses. So, we summarized the advantages of automatic and manual editing based on our comparative evaluation experiment and interview results. The advantages of the proposed system are that it requires less time and effort, and it can present map information and surrounding area information that manual editing cannot. The advantages of manual editing are that it allows the editing of conversations using common sense and a proper understanding of the situation. Conclusion and future work. As automated driving technology becomes more mature, we believe that we will be able to provide a much better post-travel UX using the many high-quality cameras and sensors. A demo video is available along with the paper, so please check it out. Thank you.